I don't know whether you remember this portion or not. Anyway, we will start. Okay, from the fourth module, from the start itself, we will start. So we're discussing about minerals. Okay, so in this module, we will discuss about the minerals and its physical properties and chemical composition of some important minerals. Okay, so first of all, what do you mean by a mineral? What is a mineral? Can you tell me what you mean by mineral? What do you mean by mineral? What is a mineral? What do you mean by mineral? You might have heard this word mineral. So what is a mineral? No one? Tell me. No one. So can you hear me first of all? Am I audible? Please respond. Am I audible? കേൾക്കാൻ പറ്റുന്നില്ല എല്ലാവർക്കും ഓക്കെ 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 താങ്ക് യു. So mineral basically it means it's a solid substance that is naturally present in the nature. Okay, it may be composed of one element or one or more elements. Okay, so that is called as basically a mineral. So mineral means it is a naturally occurring substance which is composed of one or more elements. Okay, sometimes it will be having only one element, sometimes it will be a composition of elements. Okay, so whatever it is, it will be naturally occurring. Okay, it is not artificial or it is not a human made. Okay, so that is basically a mineral means. Now coming to the physical properties of the mineral. What are the physical properties of a mineral? So if you go for examples of mineral, you can say quartz is an example of mineral. Okay, quartz, diamond, these are all naturally occurring materials. Okay, quartz, then limestone, hematite, hornblende. Okay, all these things are examples of minerals. So first of all, we will see what is the physical properties. What do you mean by a physical properties? So for a mineral, you are having basically certain physical properties. Okay, so first one is that its crystal shape, luster, color, streak, hardness, cleavage, fracture, and specific gravity. Okay, so these properties are basically called as physical properties of a mineral. So physical property basically means the property that you can touch and feel. Okay, physical properties means something that you can touch and feel. Okay, so crystal shape, if you take a mineral, the crystal shape you can feel it. Okay, if you take a luster, what do you mean by luster? We'll learn about luster. Okay, color, you can see it. Okay, by your naked eyes you can see the color. Strictness we'll learn, hardness, cleavage, all these things we'll learn. Okay, so and we'll see what do you mean by all these things. Okay, what is mean by crystal shape? All these things we'll know. Okay. Okay. So crystal shape is actually referred to the outward expression of a mineral's orderly, integral, internal arrangement of the atom. Okay. In simple words, I can say that it means the internal arrangement of the atom. Okay. So if you see here, for an example, this is the crystal shape of a quartz. Okay. So here they have showed you how the internal atoms of the quartz has been arranged here. Okay, so from this, so this is a quartz. Okay, right now in the picture that in the black you are seeing is a quartz. Okay, so generally you will be seeing a material like this. Okay, this is a quartz. Okay, so the crystal shape. So what is a crystal shape means? The internal arrangement of the atom. Okay, the internal arrangement of the atom is called as the crystal shape of a mineral. Okay, so there are different shapes in nature. That is, sometimes it will be square, sometimes it will be cuboidal, hexagonal, pentagonal, octagonal, different shapes it will be there. Okay, so some materials will be very hard, some will be loose, some will be like soft minerals. Okay, different nature is there. So all these are because of the internal arrangement of the atoms. Okay, all these are occurring due to the internal arrangement of the atom. Okay, so in this picture you can see here the atoms, that is Cl and Na plus atom. Okay, chlorine and sodium. Okay, so these two atoms are very tightly bonded here. Okay, because of the tight arrangement, or you can say because of the tight bonding, the crystal, the quartz is a solid hard material. Because of this internal arrangement of this atom, you can say that it is a solid, it is a solid hard material. Okay, so that is basically crystal means. So crystal basically means the internal arrangement of the atoms. Okay, so that's the first one, first shape. Second one is luster of a mineral. What do you mean by luster of a mineral? Okay, what do you mean by luster? You might have seen a prism. What is the specialty of this prism? Or else you can see diamonds. You might have seen diamonds. What do you mean by diamond? We can see that if you keep the diamond in light, you can see the light reflecting inside the element. The way light is passing inside the minerals. So what is the light? What is happening inside a diamond? Refraction is happening. That is, light is coming, it is entering into the mineral, and inside the light will be trapped for certain seconds, and it is the refraction occurs, and it is going outside. So you can see the glittering. You can see a glittering diamond. Okay, you might have seen, right? So luster means something that is different, opposite to that. Okay, that is, luster is the way light is reflected from the surface of the mirror. Okay, how a light is reflected from the surface. That is basically luster means. Okay, so it is the way a mirror shines or it does not shine. Okay, so that is about the diamond. There are sometimes if you take a hard rock. Okay, suppose the picture that you're seeing, a rock like this. Okay, if you take a rock like this, okay, if you keep it in the light, what is happening? Light rays will be entering and it will be reflecting back. That means the light rays are not going inside the minerals. Why? Because it is very hard. Okay, at the same time, if you see the minerals like diamonds, or you can see some of the pebbles, some white colored stones, it will allow the light to pass through it. That's why it's shining. That's why that material is shining. But at the same time, some minerals, they will not allow the light to pass through. Instead, they will be reflecting the light back. Okay, so that is basically luster, means luster of the mineral. Okay, so in the nature, you can say there are thousands of minerals which is having 1,000 different properties. Okay, so luster basically refers to the way the light is reflected from the surface of the minerals. Okay, so luster means basically how a light is reflected from the surface of the minerals. Okay, if you see this, okay, if you see this as an example, what is happening? Your light rays will be coming and it will be reflecting back. Okay, so based on that, the minerals, some minerals will be shining and some does not shine. Okay, so that is called as luster property. Okay, next, third one is important one, that is color. What do you mean by color? I don't think there is no we need an introduction for this color. Color means basically how you appear. Some will be yellow in color, some will be blue in color, some will be black in color. Okay, so that is basically the color of the minerals depends upon its composition. It varies from minerals to mineral. Okay, now how do you define a color? So color means basically that is a wavelength of the light that is reflected from the mineral surface and is not always an effective property for identifying a mineral. Okay, so you might have seen the prism or the visual. Have you heard about the visual? What do you mean by visual? Rainbow. Have you heard about the rainbow? So what is happening in the rainbow? Rainbow, a light is splitting into 7 colors. a white light, it is splitting into 7 colors. Okay, so that is how a color is occurring. Okay, so that is the wavelength. So color means basically it is a wavelength of the light that is reflected from the mineral surface. Okay, some will be dark in color, some will be light in color. Okay, some will be very medium color. Okay, so all these are because of the wavelength that is reflected from the mineral surface. Okay, and it is not taken as an effective property for identifying a mineral because the color may vary depending upon the composition of, depending upon the chemical composition. Okay. So that is basically a color. Anyway, by color we can identify a lot of minerals. Like sometimes you can say quartz. Okay, some quartz will be white, off-white in colors. At the same time, sulfur will be yellow in color. Okay, so color will be varying. So that is a third property, that is color. So anyway, you should know how the color is appearing to your eye. Okay, so color is appearing basically by the wavelength of the light that is reflected from the mineral surface. Okay, why? Because the light will be falling on the minerals and how it is reflecting back. Based on that, the color will be appearing for the mineral. Next one is streak. What do you mean by streak? Okay, this you might have done in a school time. Okay, when we are small, this you will be very curious to know about the structures that is around it. So what will happen if you get any something, some stones? If you scratch a stone against a white surface, you can see the color. Okay, so here you can see this is a hematite. For example, I'm telling this is a hematite. Okay, this is a hematite piece, and hematite is basically, okay, from the appearance you can say this is having a brown color. Okay, so if you are rubbing it against a white background, you can see a reddish brown color is appearing on the white background. This is called as streak. Okay, this is called as streak. Okay, that is this is the property that we are defining, that when you are rubbing a mineral against a white surface. Okay, sometimes if you take a charcoal, if you rub it against a white background, what will happen? You will get a black line because charcoal is basically black in color. Or if you take any what to say, any stones, any hard stones, any colored stones, and if you are rubbing it against a white surface, you will get a similar color on the white background. So this is called as a streak. Okay, so streak is the color of the mineral in powder form. Okay, so it is tested by rubbing a metallic mineral across a piece of unglazed porcelain called as streak plate. Okay, so for the standard how we are referring streak is that it is a color of the mineral in the powder form. Definitely that is right? This hematite, I'm rubbing it against a white background. Okay, so what is happening? Some portion of that hematite is getting powdered here. അല്ലെ, നമ്മളൊരു സാധനത്തിന് ഒരു white background അമർത്തിയായിട്ട് വരച്ചു കഴിഞ്ഞാൽ it is getting powdered. A portion of that, the portion that you are scratching will get powdered. Okay, so streak is basically, I'm telling technically, if you define a streak means it is the color of the mineral in powder form. Okay, so this is very important. Please note that. What do you mean? How you define a streak means that technically streak in the definition is it is a color of a mineral in a powder form. That is when you rub a stone or a mineral against a white background, what is happening? A portion will be powdered. Powder in the color you are seeing there. Okay, so that is basically streak. Okay, so how you are testing streak means you will be rubbing the metallic mineral against a white unglazed porcelain, which is called as a streak plate. So this is a streak plate. If in a lab how you test means this will be streak plate. This streak plate is made up of unglazed porcelain. Okay. So against this streak plate you will be rubbing. So by this you can define the exact color of certain minerals. Next one, hardness. So what do you mean by hardness? I didn't think hardness again need definition. Hardness means we know that we are telling certain minerals are hard, certain minerals are soft. So what does it basically mean? Okay. So hardness means the ability of a mineral to resist the abrasion or scratching. Okay. So if you take some mineral and if you scratch with your nail, you can see it will be tearing apart. Okay. There will be, if you take any hard rock or karingalla kaduthenal, how much you rub, it doesn't matter. Adinu adarnu povilla. Have you ever seen this? If you simply scratch with your nail, some minerals will tear apart. But at the same time, if you scratch on a diamond or if you scratch on a hard rock, there will be no impression left in the rocks. So that is basically hardness means. That is the ability of a mineral to resist abrasion. That means the hard rock is having more resistance power to resist the scratching or abrasion. At the same time, if you see any soft clays, for example, I'm taking talc. Okay, talc is a very soft mineral. Okay, it is a very soft mineral. Okay, if you scratch it, you can see that parts of the talc will be inside your nails. Okay, so that means it is having a very low resistance. Okay, against the abrasions or against the scratching, it is having a very low resistance. At the same time, if you scratch any diamonds, okay, nothing will happen. There will be no impression left on your nails and there will be no impression left on your diamonds of all because it is very hard. So that is basically how you, not basically, technically how you define hardness. That is the ability to resist abrasion. Okay, so one mineral of non-hardness is scratched against another mineral and harder minerals will leave a scratch in the softer mineral. Most hardness scales arrange the common minerals by the relative hardness. So how you can test the hardness means you will be rubbing a soft mineral with a harder mineral. Okay, if you scratch it, if you scratch a soft mineral with a hard mineral, you can see the impression will be left on the hard minerals. Okay. The hard minerals in the model, soft minerals in the impressions and for example, you can see based on the hardness, the minerals has been arranged here. Okay, so here two we are having a number that is called as Mohs hardness scale. Okay, Mohs hardness scale. Okay, so Mohs hardness scale, it basically gives you how hard a mineral is. Okay, it is a measure that tells you Mohs hardness scale. That is a measurement which actually tell you how hard your mineral is. Okay, so based on that Mohs hardness scale, the minerals has been arranged here. Here you can see talc is having hardness is 1. Okay, talc and the hardness is 1. This is talc, which means it is a very soft. Which means it is soft. These are not hard one. Second one is Mohs hardness scale. Gypsum is having 2. Okay, again it is soft clay. Calcite, okay, medium. Fluorite hardness number is 4. Apatite 5. Orthoclase 5. Again quartz is 7. Okay, quartz is 7 means it is somewhat hard. Okay, so has the hardness number increased, you can say it is a hard material. Okay, topaz 8, corundum 9, and finally the hardest mineral, that is diamond, which is having a hardness number of 10. Okay, the hardness number of diamond is 10, which means that is the hardest mineral. Okay, okay, so that is hardness. So if you rub a talc against a diamond, you can see the impression of the talc will be over the diamond. Okay, ഒരു കാരണവശാലും ഡയമണ്ടിന്റെ ഒന്നും അടർന്നു പോരില്ല, but the talc will be tearing apart. So that's about the hardness. Next one is cleavage. So cleavage means it is when a mineral breaks into flat surface along the planes of weak bonding in a crystal structure. Okay. So in simple words, I can define cleavage that what will happen is that the mineral breaks. You can see the inside structure of it. Right? You can see the inside sometimes how a mineral is breaking. So you can see the crystal structure. Okay. For example, okay. For example, if you take a mineral that is called as muscovite. Okay. So muscovite. So this is a picture of the muscovite. Okay. If I am breaking the minerals along the flat surface, you will get a crystal structure like this. So this is the cleavage of it. That is along the one direction. See, along the one direction. Okay. Now I'm taking feldspar. Okay, this is the feldspar. Okay, here the feldspar. So feldspar, the chemically the arrangement of feldspar it will be like this. The atoms will be arranged like this. Okay, if you break it, you will be getting a cleavage like that. That is, you will be getting along this direction, and there will be a cleavage along this direction. Two directions. Okay, earlier, if you go to muscovite, muscovite, the atoms are sorry. So muscovite atoms are arranged along one direction. Okay, atoms are arranged along one direction. But coming to feldspar, here the atoms are arranged along two directions. So you will get, see, the cleavage in this direction and also this direction. Coming to another, that is halite. You can see the picture of the halite. See this. This is the picture of the halite. Okay, so chemically this is how it is arranged. That's it in three directions, X, Y, Z. Three directions, the minerals will be arranged. Okay, the minerals will be arranged in three directions. Okay, so one mineral will be arranged in this as a flat surface, one will be in vertical direction, and another will be like this. Okay, along the three directions, it will be arranged. So if you cut it, you will get a surface like this. This is a surface that you're going to do. That is, you will get a cleavage along three directions. Coming to calcite. Okay, in calcite also, the minerals is arranged along three directions, but that is not at 90 degree. That is less than 90 degree. Okay, or less than 90 degree angle ആയിരിക്കും അത് arrange ചെയ്തിട്ടുണ്ടാവുക like this. Okay, like this. This is the calcite. And if you cut it, you will be getting a structure. Inside structure will be like this. Another example is that fluorite. Okay, so fluorite is having a four direction. It is having, it's the metal. It is having four cleavages. That is, it is called as octahedral crystal. You can see the picture. See, നാല് ഡയറക്ഷനിലും മെറ്റൽസ് എല്ലാം അറേഞ്ച് ചെയ്തിട്ടുണ്ടാവും. Okay, so it is called as an octahedral crystal. Okay, so that is basically cleavage. That is, that depends upon the arrangement of the, or you can say certain pattern of arrangement of the crystal structure. Okay, so cleavage is when a mineral breaks into flat surface along the planes of weak bonding in a crystal structure. Are you getting the cleavage? Okay. Sorry. Okay. So this to understand the cleavage better, you can see sometimes. Uh, for example, I'm telling you, നിങ്ങൾ ഒരു മണ്ണ് കട്ട പൊട്ടിച്ച് കഴിഞ്ഞാൽ, okay, if you break a ഒരു മണ്ണ് കട്ട, if you break it, what you can see, how you are seeing the inside structure. At the same time, if you are breaking any hard rock, what is you are seeing inside? The crystal structure you are seeing inside. Sometimes if you are breaking any brick, so I am just telling you how to understand the cleavage, what you are seeing. Okay, so from all these minerals, from all these materials, you will be getting different crystalline structure. Okay, so that is basically cleavage. That is when a mineral, when it breaks along its flat surface, the structural crystal structure that you are getting is called as cleavage. Okay, next one is fracture. Okay. 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 So next is fracture. So what do you mean by fracture? Okay. So I will tell you fracture basically it depends upon the how the rock is formed. Okay, how the rock is initially formed. So we all know the rock is formed by the sedimentary action. So how initially a rock is formed, that depends upon that is what the factor is depending upon. The fracture is depending upon. Okay. So basically it depends upon the rock's internal structure. Okay. So how you define fracture is that it is the way a mineral breaks when it does not break along the cleavage planes. What do you mean by cleavage planes? Okay, what do you mean by cleavage plane? So cleavage plane is a plane which allow a mineral to break smoothly. Okay, cleavage plane is a plane which allows a minerals to break smoothly. Okay, so we know that there is a certain pattern to cut certain minerals. Okay, for example, I'm telling you, okay, you can take a piece of cake. Or a cake, round little number birthday cake on there. How you are cutting a cake? You are cutting the cake from the vertical direction. Okay, from the top you are cutting the cake. Okay, so instead, if you cut the cake in a horizontal direction, then നമ്മൾ ഇങ്ങനെ horizontal ആയിട്ട് ആ കേക്കിനെ കട്ട് ചെയ്ത് കഴിഞ്ഞാൽ what will happen? What will happen? The whole structure of the cake will be disintegrated. But if you cut the cake along its vertical direction, like നമ്മൾ മുകളിൽ നിന്നാണ് കേക്ക് കട്ട് ചെയ്യുന്നത്, അപ്പോൾ ആ കറക്റ്റ് if you slice the cake, you will get a homogeneous structure of you will get a piece of cake which is having a homogeneous structure. Okay, same pattern, same structure, everything will be homogeneous. That means the cleavage plane of that cake is along the vertical direction. അല്ലെ നമ്മൾ vertical direction cut ചെയ്ത് കഴിഞ്ഞാൽ that's the cleavage direction, or you can say that's the cleavage plane of the cake. Suppose if I'm cutting it horizontally, you can see Uh, the top portion it will be having some ice creams, the bottom portions it will be having some other minerals, sorry, some other materials. Okay. Hmm. Icings will be there, cake will be there, creams will be, everything will be distracted, everything will be distracted and disintegrated. Okay. The whole thing will be jumbled. So instead, if you cut along the cleavage plane, that is along the vertical direction, you will get a perfect slice. You will get a perfect piece. Okay. So that is same thing that you're using in the minerals also. That is basically called as a cleavage plane. So the minerals also, every minerals it is arranged in a certain pattern. You have seen it. Okay, the crystal arrangement. Something X direction, Y direction. Some is arranged in X, Y, Z direction. Some is arranged in four directions. Okay. So if you instead of that, that there will be a certain plane along which if you cut it, you will get a perfect slice of the mineral. Apart from that, if you cut it along other than the cleavage plane, the mineral disintegration will occur, or you can say the deterioration of the minerals will occur. Okay, so that is what a fracture means. Okay, that is basically fracture means. That means നമ്മൾ സാധാരണ ക്ലീവേജ് ലൈൻ അല്ലാണ്ട് മറ്റേ ഡയറക്ഷനിൽ കട്ട് ചെയ്യുമ്പോൾ സംഭവിക്കുന്ന how the mineral breaks in other than a cleavage direction is called as a fracture. Okay, you can say the cake has been, if you cut the cake in the horizontal direction, it will be fractured. So same in the case of minerals also. If you cut anything apart from that cleavage planes, the whole structure will be disintegrated. Okay, so that is called as a fracture. Okay, that is called as a fracture. Next is specific gravity. So specific gravity is actually a ratio, that is the weight of the minerals compared to the equal volumes of water. So that is actually lab test we are doing. Okay. So how you are measuring a specific gravity means you will take a mineral and similarly you will take equal amounts of water. Okay. The ratio of the both will give you a specific gravity. Okay. So you can see here the potassium feldspar. It is having a specific gravity of 2.65 galena. That is another mineral which is having a specific gravity of 7.6. So 7.6 varies. Our normal stones in the stones in the specific gravity is around 2.7. Cement that you're using in the lab specific gravity is 3.15. Okay. So everything, every minerals, every materials in the earth is having a certain specific gravity. Okay. So these are some of the native elements. You can see sulfur, diamond, graphite, some of the minerals I'm just introducing here. So sulfur, that is yellow in color. This is diamond, graphite. This is gold, silver, copper, platinum. Okay. And you should also know the 10 most elements that is abundant in the earth crust, that is oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, titanium, and hydrogen. Okay. The minerals, they will be a composition of mostly these elements. Okay, the minerals that you're obtaining or minerals that you're getting will be mostly a composition of these elements. Okay, say for example, if you say muscovite is a popular mineral, okay, it is a composition of sodium, aluminum, silica, and fluorine, oxygen, etc. Okay, so like that, minerals are formed. Here also you can see the feldspar. Okay, it is a it is a mineral which is composed of potassium, aluminum, silicon, and oxygen. Okay, so so you can post your name to mark the attendance. Okay, all of you please post your name to mark the attendance. So today I'll be uploading the assignment. Okay, you have to submit at the end of the module. Okay, thank you.